Hey everyone, this is Kim Del Toro taking you through Module 3 on my Bristlebot. So in the first step of the engineering design process in Ask, we were given the following questions. How does the Bristlebot work? What are the Bristlebot's essential parts? What modifications can you make to the Bristlebot? And what materials do you have that you can use in your redesign? So essentially it was just a battery-powered motor that allowed the bristles to vibrate and allow it to move. We used toothbrush head, motor, battery, and pipe cleaners to keep it all together. The modifications that I was thinking of were to either have it draw or to make the Bristlebot move in a straight line. And the materials that I had to use in my redesign were some propellers to make it spin, cork maybe to give it some weight, pencil, some straws, just random items and objects that I found in my STEM classroom. So these are just different ideas I was kind of playing with. The propeller was too big for the robot. Once I glued it on, it was too heavy and it couldn't spin it. So then I just moved on through the things that I was trying. So in my plan, initially I had the pipe cleaners facing up to give it some wings, but I realized quickly that that failed just by watching it. So the wings up were not a good choice. It just made it go all over the place and even flipped upside down. So then I lowered the pipe cleaners and that allowed it for it to be a little more stable. So it just kind of guides it better and it didn't flip over this time. So I was thinking in my plan, what if I add more weight or give it some guardrails to control its movement just to see how that can fix it. Okay, so when I put it all together, I added a bottle cap for just more weight along with the cork. I needed something heavier, but not too heavy, just because when I did add heavier objects, it just flipped over or collapsed. The Bristlebot couldn't handle too much weight. The straws and pipe cleaner were to adjust the stability so it could have this guide take down. It is moving down, and you can see I kind of push it a little along the way because it kept getting stuck with the pipe cleaners and the straws. But in the next video, you'll see kind of a time-lapse version of the same thing, and this time I didn't touch it. I just kind of let it go until it made it the whole way back. So it was successfully able to move in a straight line with those guards on the side. So improving it, I think, again, adding more weight definitely helps. Then I just wanted to see how it would go with a pencil. So we added a pencil along with it, and it was squiggly at first, but then making some adjustments made the line a little straighter. But again, there's not much to work with the Bristlebot, so it's just kind of fun to play with and see what all it could do. So the original, without my modifications, didn't have a lot of connections among the STEM practices. You did have to look for and make use of the structure with the materials that were provided. And both the new and the original, you had to learn how to use the technology with the motor and the battery to see how it could work. And obviously we were making a little model of the Bristlebot. But the improved version did have more stars, if you will, but it did cover more on the STEM practices. My problem was how I can make the Bristlebot move in a straight line or draw. So I engineered the design that way to figure out how I could come up with a design solution, and I recognized how the technology plays in the advancement of science and just seeing how minor modifications can help it improve. Then lastly, on the specification chart, the original had a lot of no's. It didn't really present a real problem, whereas the new and improved one kind of did, only because people try to improve or make life simpler by making new inventions. Students sort of related to it because they were regular household objects, so it wasn't something that they weren't familiar with. It didn't really allow for much creativity in the original because we had those set step-by-step instructions, whereas in the improved one you did have to come up with different kind of solutions, on how you could improve it, or different kind of ways to modify it. It doesn't really incorporate a lot of science or grade level math. I think with the new one it did, only because of the science practices that it was covering. And I did have to use the engineering design process for the new one to put it all together. It wasn't so student-centered again in the first one because of those instructions, and it was for the second one, for all the ideas that had to come for that solution. I think both obviously did develop that model, and the students have to see, if this were given to students, how the technology plays in on building it. Finally, the lesson is kind of engaging and purposeful in teamwork if you have students working in partners for this, but I think they could also work on it on their own since it's only a few pieces to put together. Then in both, I only said yes for evaluating the results, because as you build it, you see what it does, how it works, or how it fails when you're looking at it all together. And they don't really have to communicate any kind of design to anybody. They're not sharing it as a group or to the class, so it's just kind of a sole activity. Thank you for listening.